Hey everyone, welcome back. So in this video we are going to discuss about the design architecture of systems like Swiggy, Zomato. So you can see a diagram on the screen. It seems quite complicated right now, but after watching this video you will have the enough understanding of this diagram and all the tech jargons mentioned here. So again, let's start with the functional and non-functional requirements of the system. So in a system like Swiggy and Zomato, let's see what can be the functional requirements. So first, user should be able to search food items in restaurant. He will be searching his favorite food and his favorite restaurant. So this is our first functional requirement. The next functional requirement would be add remove items from cart. So we will be providing cart functionality to the user through which he can order multiple foods at the same time, but this cart would be specific to restaurant. That means one card will belong to only one restaurant. In simple words, let's say you want to eat 4-5 items, let's say burger, pizza, garlic bread. So you added all those items of a single restaurant. Now let's say you want to add some other item of some other restaurant, so you will not be able to do that. And if you want to do this, you will have to remove all the items that you added previously. So you will have to remove all those items from the cart. So this is what we will be managing in cart. So this is about the second functional requirement. Next we will be having this view past order functional requirement. So user should be able to see their past orders, whatever they ordered previously. So user will have the access of that. So this is pretty much for functional requirements. Now let's discuss about a couple of non-functional requirements of our system. So user facing services, which is our search service and recommendation service. So you can see in this diagram, recommendation service and search services are our user facing services. They will be the interface for front end. So latency would be very low for these services because these services will make the home page. So basically this recommendation service and search service will make a home page for user. So latency should be very low for these user facing services, and these services really needs to be highly available because these are the user facing services. So these services really needs to be highly available. So this is all for functional and non-functional requirements. Now let's discuss about the overall design architecture of Swiggy. So here you can see a diagram on the screen. So before starting, we first really need to understand that the design architecture of Swiggy is very much similar to Blinkit system design, which we have discussed previously. Because in a Blinkit system design as well, you will be having search service through which you were searching different products. Here also we have search service through which we are searching different food items in restaurant. We will be having recommendation service, we will be having user service, and we will be having order service, payment service, cart service. So everything is similar to Blinkit system design. The only difference is that when we order something in Blinkit, we don't know in which store the request is going. Let's say we ordered 4-5 items through Blinkit. Now let's say there are 3 stores associated with Blinkit. So in this case we don't know in which store our request is going, and we don't have that right to select the store. But in Swiggy, you can order your favorite food from your favorite restaurant. So this is the only difference that we can see in a Blinkit system design and a Swiggy system design. Because apart from this, everything would be similar. User will be searching product, user will be adding items to the cart, removing items from cart. There will be recommendation, there will be order service, payment service, so everything would be similar. And one more thing, so in order to find the driver's location or nearby drivers, we are going to use Google S2 library. So here also we will be using this Google S2 library to find drivers location, nearest drivers. And these systems, these Blinkit system and Swiggy system, both are specific to location. That means we will recommend only those restaurant to the user which are near to the user's location, user's current location. So yeah, this is how we can correlate Blinkit system design and Swiggy system design. Now let's see the actual working of Swiggy system design, how it works and how we onboard different restaurant to the world of Swiggy. So first we will be having this onboarding service. So this onboarding service will be responsible for onboarding different restaurant to the world of Swiggy, and it will also onboard different menu of different restaurant. So here we will be having this onboarding service. This onboarding service will send this data to Kafka. So this event will be grabbed by Kafka, and then this Kafka will send this event to search service and inventory service. You can see arrow going towards inventory service and search service. So Kafka will send data to search service and inventory service. Now why it is sending this data to search service and inventory service? Because when we onboard, or we can say when a new restaurant will be onboarded to the Swiggy world, so we will have to tell to the user that okay, this restaurant is available now and you can order food. So when we will send this data to search service will make a post request and will store this data to Elasticsearch cluster. Now what is the reason behind using this Elasticsearch cluster? So we will discuss this after some time. So using this search service, we stored onboarded restaurants detail in Elasticsearch cluster. Now through this UI, when user will make a request, or let's say user want to search a particular food, let's say burger, so request will go to search service, and then search service will search in this Elasticsearch cluster for user's request, or we can say that search service will query Elasticsearch cluster for user's request. So this is the reason we are sending this onboarded restaurants detail to search service. Now we are also sending this data to inventory service. Now what is the reason behind this? So inventory service will be the source of truth. Let's say there are 4 or 5 restaurants available in Swiggy. So every day these restaurants will have different kind of menu. So in order to send that menu to the Swiggy world, these restaurants will use onboarding service, and using this onboarding service they will send their everyday menu to the Swiggy world or Swiggy site, and then this Kafka will send this data to inventory service. So inventory service will be the source of truth, and it will tell that what's the menu for today. Let's say some items are not available for a particular day, so this inventory service will tell that. And there's one more thing. So we have discussed about search service. So the search service will also talks to inventory service for the current availability of food, what items are currently available and what items are not available. So the search service will also talk to inventory service. Now why this search service talks to this inventory service? It is because let's say someone is searching for a particular food of a particular restaurant, and let's say that food is currently not available in that restaurant. So inventory service will be responsible for that, and when user will make a search, the search service will talks to inventory service for current stock, current availability of that food, and if that food is not available, then search service will simply tell that this item is currently not available. And that will make a good user experience, because let's say if we do not update about current availability at that time during search, and let's say user proceeds to buy, and during payment he got to know that the item is not available, then this will obviously bad user experience. So this is the reason we are updating user about the product availability while searching. So yeah, this is about inventory service, and this is about both the consumers sitting on the other side of the Kafka queue, which is this search service and inventory service. Now let's talk a little more about search service. The search service will be a user facing service, as we discussed earlier, and we are using Elasticsearch cluster for search service. Now what's the reason behind this? Let's say user wants to search a food of a particular restaurant, and let's say he doesn't know the spelling of that restaurant, and let's say the spelling is very complicated, so he can do typo, and even after typo we want to suggest a correct name to user. So Elasticsearch cluster would be a great choice for that, because it provides fuzzy searching functionality, and it also provides auto completion functionality. So after typing few characters of the restaurant name, we can have the suggestion if that restaurant is famous or restaurant is very popular. So this is the reason we are using Elasticsearch cluster for search service. Now this search service also talks to this user service. Now why this search service talks to this user service? Because all the user related information, it can be user address, user email ID, user phone number, everything will be stored in this user service, or we can say MySQL database running on top of user service. So all the details will be stored in this MySQL database of user service. So in order to get user's address, where he is currently present and what's his current location, so in order to get user's address, user's location, the search service talks to this user service just to check whether the item is deliverable to a particular location or not. So this is the reason the search service talks to this user service. Now let's talk a little about this user service. So this user service will be the source of truth for all user related information. It can be user address, username, user phone number, and all the other user related information. And for user service we are going to use this MySQL database, because data is going to be very structured and it can be present in the form of table. So we will be using MySQL database for user service. This user service uses a cache, because a lot of times other services will call user service to get information about a particular user. So user service could potentially call MySQL all the time for all the requests, but that probably not an efficient choice. We can use cache memory for user information, because this information is not going to change very frequently. So this is the reason we are using cache memory here, which is our Redis. So this is all for this user service. This user service will also have the authentication mechanism, and this is the reason it is a user facing service for front end, which will be our login page. So this is all for this user service. Now let's discuss about few more services of our system. So we have discussed search service, inventory service, user service. Now let's discuss a little about this cart service. So in cart we will be adding items, we will be removing items from cart. So this cart information is going to be very frequently accessed. User will be adding items to the cart, user will be removing items from cart. So this cart data is going to be very frequently accessed. So are we going to use any cache memory for that? Actually yes, we will be using cache memory for cart service, but we also need a permanent data store where we can store this cart data permanently. So this is the reason we are using this NoSQL database for cart service. Now why we are using this NoSQL database? Because in restaurant each item can have different add-ons, different variants. Let's say for pizza it can be small, medium, large. We can have nested modifiers. It can be veg, non-veg. So burger can be veg or it can be a non-veg. So we can have different add-ons, and for each item there can be different properties. So this is the reason we are using NoSQL database for cart service. Now, very obvious question, why we need this NoSQL database or any permanent database for cart service? So let's try to understand this with the help of example. So let's say you have a mobile device in which you are using your Swiggy system, and you added 4-5 items to the cart. Now let's say you changed your device. Let's say you logged into your laptop with same credentials. It can be your email address or it can be your phone number. So you logged into some other device. Now in this case as well, you should have access to all the items that you added to the cart. That means all the items that you added to the cart in this device should also be visible in this device cart. So in order to do this, in order to maintain this, we need a permanent storage, and this is the reason we are using NoSQL database for cart service. So this is pretty much for cart service. And there's one more thing, this cart service also interacts with the inventory service, because inventory service is a source of truth and it will tell whether the item is currently in stock or not. Now let's try to understand this with the help of example. So let's say I added 4-5 items to the cart on Tuesday. So I added 4-5 items to the cart on Tuesday. Now on Wednesday I attempted to buy them, or I attempted to order them. Now it might be the case that among all the 4-5 items, few items are not in the menu on Wednesday. So in this case, this inventory service will tell to the cart service that okay, today this item is not available, so it will come up with the not available tag or out of stock tag. So this is pretty much for cart service. Now let's discuss about this order service, payment service, and how they interact with each other. So when user clicks on place order button, this order service will get invoked. And let's first discuss about database choice for order service. So we are using this MySQL database for order service. Now why we are using MySQL database for this order service? Because data is going to be very structured. We will be having order ID, we will be having different orders, customer name, we will be having his address. So everything will be well structured, and it can be present in the form of tables. So we will be having different tables, some with order information, some with customer information, some with item information. So we will be having different information, and there are a lot of updates happen on this SQL database, MySQL database, for each order. Sometimes order status will be created, sometimes order status will be delivered, sometimes order status would be cancelled. So for each order we will be having different status, and there will be a lot of updates happen on this SQL database for each order. So we need to make sure that all the updates are atomic and they can form a transaction. So we have to make sure that there will be no partial updates, and MySQL database provides it out of the box, so we would leverage it here. We are using Redis cluster as well for this order service. Now why we are using this Redis cluster? So we will discuss this after some time. So let's discuss what happens when user clicks on place order button. So when user clicks on place order button, there will be entry created in the MySQL database that order has been created, and we will store order creation time and order expiration time in Redis cluster. So let's say your order is created at 10 a.m. and order will be expired at 10:05 a.m. So this entry will be stored in Redis cluster. So we will store this in Redis. Now this order service will redirect user to the payment service. Let's say if payment gets successful, so this payment service will send a callback event to order service that payment has been successful. So we will update the entry in database that order has been placed now. and we will delete the entry from Redis cluster. So we added this entry in Redis, so we will delete this entry if our payment gets successful. Similarly, let's say order is created and because of some XYZ reason our payment gets failed. So in this case, this payment service will send callback event to the order service that payment has been cancelled, payment has been failed. So in this case, order service will mark an entry to the database that order has been cancelled. And in this case as well, we will store this entry from Redis cluster. So we will remove this entry. Now you might be thinking that what is the need of this entry? We are just adding this entry when we create a new order, and when our payment gets successful or our payment gets failed, so we just simply delete this entry. Then what is the need of this entry and why we are storing this in Redis? So let's try to understand the third case. First we discussed when payment gets successful, second when payment gets failed, and let's discuss the third case. Let's say user clicked on place order button and order will be created in the MySQL database with the tag that order is created, and we will add this entry to the Redis that order is created at 10 AM and order will be expired at 10:05 AM. So we stored this entry in Redis cluster. Now let's say user went to this payment service payment gateway page, and because of some XYZ reason he just left the page and he just closed the browser. So in this case, payment service will not send any callback event to this order service. So order service will not get any update from payment service. So what will happen in this case? So in this case, this Redis will help. How? Let's try to understand this with the help of examples. So let's say at 10 AM new order will be created and this entry will be stored in the MySQL database with the tag that order is created. And we will also store this entry in Redis cluster. Why we are storing this in Redis? So let's try to understand this. So at 10 AM new order is created and at 10:05 AM this order will be expired. So when order will be created, this order service will invoke payment service for making a payment, and let's say till 10:05 there was no update from payment service, or let's say payment service did not send any callback event. So in this case, this Redis will update order service that there's still entry in the Redis. So this order service will get to know that okay, there's some issue on the payment side because we did not get any payment success event or payment fail event. That means user went to payment gateway page and because of some XYZ reason he just left the browser. So this is the issue. So this order service will get to know that okay, this is the issue. So he will simply mark in entry in database that order is cancelled. So this is how Redis helps in the third case when user simply left payment gateway page. So this is how our payment works, and this is how payment and order service interacts with each other. Now let's say when our payment gets successful, so in this case this order service will send two events to two different services. First it will send event to restaurant service that okay, there's some XYZ user and he wants to buy this food. So he will simply send this data to restaurant service. Then this restaurant service will contact with one of the restaurant. It can be a particular restaurant or it can be dish specific. So this restaurant service will send this event to restaurant and they will start preparing your food. Similarly, this order service will also send one event to delivery service. Now why it is sending event to delivery service? Because we will also have to find nearest driver. What are the available drivers close to user and close to restaurant? So we will have to find out this. So this is the reason we are sending two different events to delivery service and restaurant service. So this is pretty much for order service, restaurant service, delivery service and payment service. And we also discussed how order service and payment service interacts with each other. Now there's only one service left, which is this recommendation service. So let's discuss a little about this recommendation service. So first we really need to understand what we should recommend to user. So we should recommend different foods to user based on their previous interaction. Let's say if user searched for veg cheeseburger, so we will capture this and will send this event to Kafka. So you can see an arrow going towards Kafka queue from this search service. So we will send this data to Kafka. Whatever user is searching, we will capture that data. Whatever user is putting to the cart, so we are also capturing that data. You can see an arrow going towards this Kafka queue. So if user is adding item to the cart, so we will capture this, what user added to the cart and how many times he added that item to the cart. So we will capture everything. Then this order service will also send an event to Kafka, which will tell that what user is ordered. So we will send all these things in the Kafka, and there will be Spark streaming on top of Kafka, who will perform some aggregations and will perform some other calculations, and there will be Hadoop cluster who will do some machine learning operations and other operations to generate a recommendation feed to user. So after going through with different phase, this Hadoop cluster, this Spark streaming, we will get recommendation feed for user, and then we will send this to recommendation service, and then recommendation service will be responsible for recommending different products, different food items to user. So this is pretty much for Swiggy system design. Now I hope you have enough understanding of this diagram and all the tech jargons mentioned in this diagram. So yeah, this is all for this video. We'll see you in the next video. So till then, bye bye, show some love, thanks.